We know that every CPU could execute a set of instructions which we call the ISR of that CPU. Now, the format of each instruction is like this, that you would have opcode and operands. But what are these things? For example, if I say 4 plus 5 plus is the opcode, this sign is the code that it means I want the addition to be executed on the operands of 4 and 5. So 4 and 5 are operands, and this sign is the opcode for the addition. The length of the opcode in 8085 microprocessor is 1 byte long. So is the IR register, which means this is the part of the instruction which comes to the IR register in the CPU to be decoded, and so the corresponding signals to be generated. The length of the instructions in 8085 microprocessor could be 1 byte, 2 bytes, or 3 bytes long. Now, about these two situations, it makes sense. 1 byte would be the length of the opcode, obviously, and then the length of the operands based on the number of the operands that we have might be 1 byte or 2 byte, which would be the addition of those two to form the final instruction, the length of the instruction. But what about this? We know that the instruction format is both opcode and operands, and we say that the opcode length is always 1 byte. Does it mean that in these situations, in this instruction or the instructions in the type of the instructions, that the length of it is equal to 1 byte? Does it mean that we don't have operands? Well, no, actually, it's not true. In those kind of instructions, the operands are implied. Now, I would clarify everything with examples. But the methods that we provide or operands in each instruction is called addressing mode. As an example, let's say I want to give you an example of all the variable length or the different length of the instructions in 8085. The first one is this one. Let's say I want to tell you what is the instruction for moving the contents of the B register in the A register. This instruction does this. The contents of the B register should be moved into the A register. Let me change the color. The opcode for this instruction is equal to 78 in hex, or in binary it would be equal to 01111000. What this means is that the programmer would write this one in a memory address in the RAM, which the PC is pointing to that memory cell. This data has been fetched and put inside the IR register. Now the CPU would look at this data and it would figure out that it should move or transfer the contents in the B register into the A register. All of those things has been done with just 1 byte. The instruction length is 1 byte. Both the opcode and also the operands are implied in this instruction. Even though it seems like saying this addressing mode is of the implied version, saying that this is the implied addressing mode of instructions, but this is called the register mode. You see, the implied mode would be a better name for this, but actually the implied mode is like another instruction in the 8085. It is called CMA, which means complement the value of the A register. The opcode for that is equal to 2F. By this, 2F in hex is equal to 0, 0, 1, 0, 1, 1, 1, 1. By this, we mean that whenever the value in the IR register in the CPU is equal to this, the CPU would not all the bits inside the register. We will talk about all the different instructions in the next section, but right now I wanted to tell you that these type of instruction is called implied, but any kind of instructions which has registers in it and the length is equal to 1 byte, we say that it is the type of register addressing mode. Again, both of them, if you are trying to like pass an exam or something like that, you should understand the difference between implied version and register version. But if you're just learning for yourself, then obviously you only learn something if you need it. So in that case, it's better if you imagine both of these versions as implied versions, since uh, we don't provide any operand in our instructions. Our instruction is just 78 hex or 011111000 in the binary, and all the data regarding the operands are already implied in the instruction. So both of these instructions were of the type of 1 byte long instructions. Now I want to give the example of 2 bytes and 3 bytes long instructions. First one is move. But why would we want to create other addressing mode in general? For example, can't you say uh, for always I want to just use the same implied instructions, never ever change the method that we provide the addressing mode, and therefore you wouldn't have to learn more, right? It is a very valid and logical question. So imagine instead of moving the data from B to A register, I want to move the data equal to 50 in hexadecimal inside the A register. So right now you say, well, just like before, I say I create an instruction for move A and 50 hex, and maybe reserve the next byte, for example here, the next opcode like 79H, to be referring to be the opcode of these instructions. So whenever 79 in hex is in the IR register, the CPU would move the value of 50 inside the A register. It just knows that 79 opcode means writing the value of 50 in A register, and that is, well, a valid solution. But the problem is, what if you want to move the value of 51 hex in A register? Well, you say, I just reserve the next opcode, 80 hex for 51H. Meaning, if I have 100000 in binary in the IR register, the CPU would write the value of 51 in hex inside the A register. But what if you want to move the value of 52 in hexadecimal? You again say 81, but this would go on and on. We have, at the first glance, you'd say that we have infinite number of different values, but that's not actually the case. Since the length of the A register is equal to 8 bits, it could have the values of 0 to 255. So what you could say is to create 200 or reserve 256 different opcodes for implying operands in this way. Move A and 00H to move A to FFH. Every one of these instructions would have one specific opcode for itself. The good thing about this is that all the instructions would be of 1 byte length, and we never ever have to learn any other addressing mode to create any addressing mode. All the addressing modes are just implied. All the values are implied in the same opcode. What is the problem? The problem is that we said opcode is equal to 8 bits, and all instructions would have at least opcode. The length of the opcode is, if it is equal to 8 bits, we could have 256 different instructions. Opcode is the part of the instruction which goes to the IR register. So is the length of the IR, right? So we could have only 256 different instructions in the 8085 microprocessor, meaning all the instructions should be spent to just create one single instruction, move the value inside the A register. Only the one. What about moving the values inside the B register, or just complementing the value of A register, jumping, and all the other possible instructions? So that's the need that I wanted to give you, the feel of the need that we need to create another method of providing our operands. The way that we do it is this way. I say move A, I create an opcode for move, let me say, write it in this way. I say move I A and the byte. What it means is that I say the opcode of 3E in hex, let me change the color, which in binary would be equal to 00111110. This opcode, I reserve it for moving the value immediately to the A register. Then the byte would be provided by the programmer. As an example, let's say you as the programmer want to do the same thing here. Move the value of 50 in hexadecimal inside the A register. So what you do in this case is that you should write your program inside the memory, right? Let's say this is the address of 100, 101, and so on. So in here, you just write 00111110 or 3E in hex. Then in the next memory cell, you write the value of 50 in hexadecimal, which is equal to 01010000. This is 50 hex. The PC, the value of the PC, let's say, is pointing to this location. The CPU would fetch this value and put it inside the IR register. The IR would contain the same value, 3E, right? So by looking at it, it understands that this is the opcode for moving some value inside the A register. But what is that value? That value is 1 byte. The length of the instruction, CPU using this opcode would understand that the length of the current instruction is not 1 byte, but is actually 2 bytes. And the second byte should go to the register A. So it would move this value and write it inside the A register, and you would have 50H in the A register. Now, if I could just tell you, just tell me the steps that the CPU has to take in order to execute this instruction, you would say, well, first of all, the CPU did some fetching. After that, it wrote some value from the it just read a value from the next memory cell inside the A register. So we say it has done one fetch, which is the opcode read. Actually, reading the opcode means fetch, and then it reads the next memory cell. We talk about what these things are. I just wanted you to just name the steps. It's just so simple. Now let's say the programmer, we haven't solved anything. Let's say now as the programmer you want to move the value of 51 hexadecimal inside the A register. So again, you say the same value, 3E or 00111110 is the opcode for move I something in the A register. So this wouldn't change in the same location. But now, instead of 50, we say 51 hexadecimal. Again, one fetch would happen. This would go inside the IR register, 3E. The CPU would understand that this instruction, the length of this instruction is 2 bytes. And it is indicating that the byte in the next memory cell should be read into the A register. So it would just put the value of 51H into the A register, and this could easily be done for all the other values. Now let's look at the benefits and the problems of these two addressing modes. Well, in this way, in the first one, we said that all the instructions could be implied, but we would run out of the opcodes. So the implied version for moving immediate values is completely out of the picture. But in this way, by using this addressing mode, we could just use one single opcode of 3E, but the length of instruction is not 1 byte, but it is 2 bytes. 1 byte would be the opcode for telling the CPU that I want the next byte to be read inside the A register. So the operand would be provided by the second byte. Therefore, this addressing mode is called immediate addressing mode, a good name for it, because you are not implying anything. You are not using well, not any register. As I said, that's the reason that I'm saying that the name of implied addressing mode for both implied and registers is better. So in this addressing mode is called immediate addressing mode because you are providing bytes immediately in as part of the instruction after the opcode.